today we're going to go from just linear inequalities to systems of linear inequalities. Okay, so remember yesterday we were just graphing those lines and then shading all the solutions. Okay, today we're graphing a system. And what's a system mean again?
Like multiple lines?
Yeah, you have multiple lines. Okay, so a system means you have more than one, right? So we're going to have more than one inequality on the same graph today. All right, so we're on page 160. We got 162 of our student journal. Okay, I want you to work through exploration number 1 with a partner there. Okay, match each of the linear inequalities with its graph and explain the reasoning. Hi. Okay, and then after we do exploration 1, I want you. We'll talk about it, and then we'll go on to exploration 2. You're welcome to start exploration 2 if you finish it, but okay, how can we graph these systems? So go for it. We'll work together. Check it out. So I've shaded those in there. Check it out. Try to match them up real quick. Okay? Here we go. So number 1, which inequality is this one? Is A. Yeah. Inequality 1. Everyone agree? Yeah, how many of you just matched the 4 here and you said, well, that's a 4 there, and that works out? Did anyone do the intercepts? The XY intercepts? How many changed slope-intercept form? How did we match it? Go ahead.
Well, first you guys put it, or what I did is I put it in y equals mx plus b form.
Okay, y equals mx plus b, we call that, anyone know? Slope-intercept form, right. So subtract our 2x and plus 4. How many did that? Okay. And then, so you use your y-intercept?
Yeah.
Down 2 over 1. How many of you got, this is graph number 1? Okay. So what form, what did you use, Kyla? What did you use? Did the same thing as that? How many did slope-intercept form? Okay, pause. How many did slope-intercept form? Okay, ask your neighbor if they use slope-intercept form. Okay. So we found out this one's 1, this one's 2. Everyone has 2 colors. I want you to graph them down here now using 2 different colors. So if you're going to use, say, like that color here and this color here, like leave yourself a key there so you know which color. Okay? Go ahead and put them on the same grid there. Okay, so when you graph both and use different colors, you get this messy shaded region. Now, I've seen a lot of students in the past, they really like to show that darkened area. They really like to darken it in to make it clear that that's the overlapping region. Well, that overlapping region is the solution to this system. That means any point that lies in this region would satisfy both these equations or inequalities. All right? Ayla, you with me? Yeah? It's a good book, huh? Is it about math? No? Oh, I like math. Okay. Did you guys hear the Seahawks? How many watched the Seahawks this weekend? Did anyone hear what Doug Baldwin wants to be when he grows up?
A math teacher.
A math teacher. Dude's going to get his master's degree and wants to be a math teacher. Isn't that sweet? That is. Him and I should just switch spots. I could be do his job, and he could do mine. Yeah, I just send him a jersey with my name on the back. That'd be nice stuff, dude. That is awesome.
They have
Yeah, I know. He didn't do too hot. Hey, I'm telling you, dude, that made my day. He wants to be a math teacher. I was just pumped up to come to work the next day. I was like, dude, I have his dream job. That is awesome. I'm just saying. All right, so any point over here is going to work out. So if I picked a point, actually, everyone find a point in here to check. Test a point in this region right here to check in both your equations. Inequalities. Hey, very good. You guys, those of you who test 0, 0, that one works. There's only one reason why that one works. Well, there's 2, I guess. It's in the shaded region. However, it's actually on a line. Okay? Why could it be a solution on this line? How do we know picture-wise? Lily?
Because in the inequality, it's as the line underneath
Good, yeah, it has the or equal to piece, right?
Yeah.
And picture-wise, what's the line?
Solid.
It's a solid line. Okay, so yeah, 0, 0 works. In fact, we put it in, we get 0 is less than or equal to 4, which is true. And then over here, that becomes 0, 0 is less than or equal to 0. It's actually equal, that works. Anyone pick a different point other than 0? Brendan, what'd you use?
Negative 2, 2.
Negative 2, 2. So like negative 2, 2. It's hard to see them in here, but if I put negative 2 in for x, that gives me negative 4 plus 2. That is negative 2, which is less than or equal to 4. And put negative 2 in for x, that gives me negative 4 minus 2 is negative 6, which is less than or equal to 0. Very good. All right. What about this spot right up here? We had region 2 right here. Are there any solutions up there?
Mm-hmm.
Is there a solution to both equations?
No.
Inequality? Now tell your neighbor which solutions lie up in this region.
Only two.
Is it for inequality 1 or 2? Okay, everyone on your fingers, which inequality solutions lie up here? Yeah, it's inequality 2, right? It's this color. Which solutions lie down here? Inequality 1. Which ones lie over here? None of them, right? I mean, if we pick a point somewhere over here like 4, 0, and I put 4, 0 in, 2 times 4 is 8, plus nothing is not less than or equal to 4. And 2 times 4 is 8, minus nothing is not less than or equal to 0. This point doesn't satisfy either of them. Okay, whereas points down here will satisfy this one, but not this one. And points up here will satisfy that one, but not that one. There's points in the double shaded satisfy both. Okay. Any questions there? Now I want you guys to look at this. This is my graph of when I usually do the work before you guys do. Now I circled different colors, but I didn't use different colors. But what did I do there different than this graph? Lily?
In the one with the two different colors, you shaded the bottom, I don't know how to say it, the bottom coordinate more than in the other one.
Okay. So I have more shading down here. Yeah. Bobby?
You only shaded one region?
Yeah, I only shaded one region. What region is that? Audrey? Yeah, that's my overlapping. Does everyone, you guys see my arrows here?
Mm-hmm.
Look at my arrows. Okay, when I show this in class, I generally give you kind of a hint on where to shade. Okay, so I want to do another one together here in a few minutes, and we're going to try to go this route as well. And you can use different colors. You can do it this way the whole time as well. Okay, but I'm going to kind of go both routes so you have an option there. But before we do that, I want you to answer the questions on page 163. Okay, take about 5 minutes. Maybe 7 minutes, work with your partner, answer those questions there. Okay? Okay, everyone's eyes and ears focused up here, please. Now, I will tell you that sometimes when you start getting questions where you have to read and write, especially in math, that sometimes we just stop working. Okay? Now, some of these questions are a little different, and some of them just make you think about how to communicate math. That's kind of the purpose. The letter B. Everyone tell your neighbor the answer to letter B. What you got there? Like, read your answer to them. What'd you get?
Well, what?
Just read exactly what you have. Hey guys, I'm going to have you read exactly what you have, and I want to talk about it as a class because this isn't something we've done a lot of. Okay? So go for it, Bobby.
The unshaded region means no solutions.
Okay, describe each shaded region. What does the unshaded region represent? It means no solutions to either inequality. Okay? All right, Jake, what did you get? No, read exactly what you have. If you don't have anything, you just say I don't have it.
Wait, for 3?
No, letter B.
Oh, I said it means that there's no solution.
It means there's no. So what's it? Just curious.
What's what?
What's it? You said it means.
Oh, the unshaded region.
So the unshaded region means no solution. Okay. What does the shaded region mean? Chelsea, what do you have there?
The shaded region of the graph represents a solution.
A solution. Okay. So listening to that, are there ways to be more specific? The shaded region of the graph represents a solution to what? To both inequalities, okay? So you have a really good start. And then what you guys said about the unshaded region, it means it's not a solution to? Yeah, to either inequality there, okay? You could also talk about the other regions, right? We not only did we have the double shaded region and a no shaded region, we had these singly shaded regions. Those are solutions to only one of the inequalities. So communicating that's a key piece, and that's going to be a big deal on these upcoming exams. That's why the books start looking a little different. Not to mention it allows you to actually understand the math a little better. Okay, this was kind of a weird one. How can you graph a system of linear inequalities? Most of you just go, well, I just graph it. All right, well, what do you do first? You do just graph the line. You graph the line, but what do we do after we graph the line? Yeah, we shade. How do we know where to shade? What have we been doing? Cool. Choose a point. So you graph the line, you test a point, and you shade over that point if it's what? True. And you shade away from that point if it's false. Okay? So it's really going through and step by step explaining what you're doing. These kind of questions are the things that I start asking myself when I'm about to teach you the lesson sometimes. Okay? Don't goof around, man. What are you doing? We're even recording about trees. Okay? All right. Number 4. When graphing a system of linear inequalities, which region represents the solution of the system? Marie, what do you think? Yeah, where the two shaded regions cross over, overlap. Okay? Number 5, do you think all systems of any linear inequalities have a solution? Who says, yep, they all have solutions? Who says, nope, there might be some without solutions? Well done. When would they not have solutions? Go ahead and tell your neighbor there. When do they not have solutions?
Maybe when the problems overlap each other, like if there's
Trees. Trees have solutions. They might have
the
shade.
same except different.
All right. When might they not have solutions? When they don't overlap. So when would they not overlap? Yeah. Good. Bring. Okay, no solution. What would that look like, Caden? Okay, so let's say I have parallel lines. Couldn't I have an overlapping region in between those parallel lines? It could overlap here, right? I could shade up on one and down on the other. Is there a situation, though, in those parallel lines when I could have an overlapping region where, a situation where they don't overlap?
Yeah.
Go ahead and describe to your neighbor how those parallel lines could have regions where they don't overlap. All right. Jaden, what do you think? Gents? If they're both shading up? So if this one shades up, what if this one shades up? Will it overlap eventually? Yeah, probably would. So they couldn't both shade up. Lily?
When they're shading in opposite direction.
Yeah, when maybe this one shades up, but this one shades down. Okay? Now, really not like this one shades down and this one shades up, right? But they overlap here. In this case, the top one has to shade up, the bottom one have to shade down. Okay, that would be a no solution, yeah. All right. Write a system of linear inequalities that represents this graph. Okay. What line is this, X or Y? This is a Y equals. Tell your neighbor why it's a Y equals.
Because it's horizontal.
Why is it a Y equals, Keegan?
It only has a y-intercept.
Yeah, it only has a y-intercept. The y-intercept is at 3, so it's a y. Are we shading up or down from there? We're shading down. So that's a less than symbol. Is it solid or dashed?
Solid.
Solid. So we have to have the equal to. Okay, how about this line? First of all, it's dashed, but is it an X or a Y? X. So JC, where does it cross X? So cross right here, right? So what point is that? Go ahead, Mackenzie. Help her out. Yeah, it crosses at 2 on the x-axis. Okay? Solid or dashed? Dashed means, tell your neighbor what the dashed line means. Oh, is that a solid line?
Yeah.
Oh, it looks dashed on mine. Sorry, that's a solid line. All right, we already know what solid means. That makes it less fun. Is it less than or greater than?
Less than.
Less than. It's shading the smaller things on X, so it's less than or equal to. All right, there's my system, man. A lot of times we bracket a system with brackets like that. That's cool. Okay, we got to kind of be done with this. Any questions? All right, what I want you to do before we move into our assignment, I want you to summarize your learning here. So we're on page 164. I want you to go through and just, in your own words, define what you need to, make any notes to yourself, and then you have this picture down here to help yourself out as well that shows where the solutions are. Okay? Take about 2-3 minutes to do that. Hey, are there any questions? All right, your assignment today is page 165 and 166 in your journal. Okay? So if you take a look at it, reading through the instructions, make sure you read each set of instructions so you know what's expected before we start here. Okay, so go through each set. Make sure you understand what's expected. There's 165, then 166. If you have one of the copied versions, the shaded regions might be a little tougher to see, so if you're not sure, look at someone else's workbook. Okay, and make sure you get the correct regions down. So read through and make sure you get any questions answered about what's expected there. I'll be around helping out.